Welcome to my video course on mastering ERTMS ETCS signaling systems. Today, we're diving into exactly how a train's onboard unit handles, well, all sorts of different track conditions. If you've ever wondered how modern trains seamlessly shift between full-on automation and manual control, all while maintaining absolute safety, you are definitely in the right place. Let's get started.
What you're looking at here is the driver-machine interface, or DMI, inside an ETCS-equipped cab. Think of this as the train's command center. The train-borne ETCS Level 2 subsystem is incredibly intelligent. It takes on various statuses and operating modes to guarantee very specific safety levels. Depending on where the train is and what it's doing, it actually shifts modes. And each of those modes is indicated by a specific symbol right there on the screen. It keeps the driver perfectly in the loop at all times. So here's our quick agenda for today. First, an intro to ETCS modes. Second, normal and sighted supervision. Third, manual and shunting operations. Fourth, unfitted lines and defaults. And finally, number 5, safety interventions and trips.
All right, let's jump right into Section 1, Intro to ETCS modes. You know, an operating mode isn't just randomly chosen by the computer. It is strictly dictated by either the available track data being fed into the system or by intentional direct input from the driver. Basically, these modes act as the absolute rulebook for how the train behaves at any given moment. They dictate the system's level of autonomy and really the distribution of responsibility between the computer and the human driver. Every single mode guarantees a specific safety level, and as we just saw, they're displayed as a symbol on the DMI. Depending on the exact situation, they're either triggered automatically when certain conditions are met, or they're selected manually.
Moving right along to Section 2, normal and sighted supervision. Let's explore the primary supervision modes. These are used when the train has a clear, established communication link with the trackside infrastructure. First up is full supervision, or FS. You can really think of this as your standard optimal state. Full supervision gives the train a normal, non-permissive movement authority with full protection. So the train is permitted to run at the maximum speed shown, and it's strictly supervised against a dynamic speed profile. Now, the driver can't just push a button to select this mode, right? The system enters it automatically, and only when all the necessary train and track data is perfectly available on board. Next up is on-site, or OS mode. So what happens when a movement authority allows the train to enter a track section that might already be occupied by another train, or maybe even blocked by an obstacle? That's where OS comes in. In this mode, the system still watches your speed against a dynamic profile, but there's a strict rule. The driver must proceed at a speed that allows them to physically stop short of any obstruction. Just like full supervision, this mode is entered automatically by the onboard unit when commanded by the trackside. Let's put them side by side to really see the difference. In full supervision, the ETCS system does the heavy lifting. It takes full responsibility for ensuring a clear path and monitoring that maximum permitted speed. But in on-site mode, while the system still monitors the speed limit, that crucial visual responsibility of detecting obstacles shifts directly to the human driver. It's basically the system saying, hey, you're authorized to move, but you absolutely must use your own eyes to make sure the track ahead is clear. Let's move into Section 3. Manual and shunting operations.
Okay, so now we're talking about special manual movements, things required for yard work, degraded operations, or highly specific local maneuvers. This brings us to staff responsible, or SR mode. It's a pretty unique mode because it actually allows the train to be moved under the driver's own authority on an ERTMS-equipped line. But don't get the wrong idea, it is definitely not a free-for-all. The ETCS system still enforces a strict ceiling speed. Plus, a given distance is also supervised. It essentially acts as a tight digital leash to prevent runaways while the driver is operating manually. Then we have shunting, or SH mode. As the name obviously implies, this is used strictly during shunting movements, which can be initiated by the driver or ordered by the trackside. The train's speed is once again supervised up to a ceiling speed, but, and this is a really crucial point, merely seeing the shunt symbol pop up on the DMI is not an authority to move the train. The driver still needs distinct operational permission to actually start rolling. Even in these manual modes, the ETCS retains some incredibly strict safety nets. For example, if you're in staff responsible or shunting mode, the trackside can send a list of expected Belize groups. If the train passes a Belize group that isn't on that list, boom, the system intervenes. It'll also jump in if it receives a specific stop if in SR or SH command from a Belize,
or if the train overpasses that given distance limit while in staff responsible mode. On to Section 4, Unfitted Lines and Defaults. So, what exactly happens when that advanced ERTMS track equipment is just missing? When a train leaves the digital safety net of ETCS and drives onto lines not fitted with ERTMS, it enters unfitted, or UN mode. In this state, that advanced trackside data is totally gone. The DMI strips away all the complex information and basically just displays the train's speed. The system now has to rely purely on national data to supervise the ceiling speed, along with any temporary speed restrictions that happen to be programmed in.
Next up is standby, or SB mode. Think of this as the absolute baseline state of the train. It's the default mode automatically selected when opening or shutting down the driver's desk. In standby, the onboard equipment acts kind of like a giant electronic parking brake. It actively performs standstill supervision, making absolutely sure the train remains safely and securely locked in place and doesn't roll away.
And that brings us to our final section, Section 5, Safety Interventions and Trips.
So when everything else goes wrong or a limit is breached, how does the system actually protect the train? Well, through trip or TR mode. This is it, the critical, non-negotiable safety intervention. Trip mode is automatically selected the exact millisecond a movement authority is exceeded. The system doesn't wait to ask for permission. It immediately triggers an emergency brake demand to bring that train to a rapid, complete halt.
Here is exactly how that sequence plays out. First, the train exceeds its permitted movement authority. Second, the onboard unit instantly and automatically shifts into trip mode. Third, the emergency brake demand hits, physically stopping the train. Fourth, the specific reason for the trip is displayed directly on the DMI, so the driver knows exactly what boundary was crossed. And finally, operations simply cannot resume until the driver manually acknowledges the trip. It's just a brilliantly designed, tightly closed loop of safety.
So, having explored everything from the optimal full supervision to the ultimate fail-safe trip mode, I want to leave you with this to consider. Which ETCS mode provides the right balance of autonomy and manual control for your specific rail network scenario? Understanding these modes is absolutely key to grasping modern railway safety. Thanks, we can see you next video.